Hi students, good evening. Now I am going to discuss about limits problems. First one, f of a equal to 2, f dash of a equal to 1, g of a value is minus 1 and g dash of a equal to 2. Then calculate the given limit. Limit extends to a, g of x into f of a minus g of a into f of x by x minus a. Limit extends to a, g of x into f of a minus g of a into f of x divided by x minus a. If you substitute x is equal to a directly, this is g of a into f of a, g of a into f of a. Both the values are equal and here denominator also a minus a. It will become 0 by 0 form. It is called indeterminate form. Whenever it is indeterminate form, you have to apply L'Hospital rule. L'Hospital rule means limit extends to a, the function values are reaching to 0 by 0, differentiate numerator as well as denominator and then apply limit, which is equal to limit extends to a by using L'Hospital rule. F of a is constant, g of x derivative is g dash of x minus g of a is constant, f of x derivative is f dash of x divided by x derivative is 1, constant derivative is 0, no need to write. After completing of derivative of both numerator and denominator, you have to apply the limit. X is equal to a, substitute wherever it is. F of a into g dash of a minus g of a into f dash of a by 1, no need to write. These values we have already. F of a value is 2, g dash of a value is 2, minus g of a value is minus 1, f dash of a value is 1, which is equal to 4, minus of minus 1 plus 1, 4 plus 1 is equal to 5. Therefore, the given limit value is equal to 5, which we are observing in the third option. Come to the next question. Let f from R to R be such that f of 1 equal to 3 and f dash of 1 equal to 6. Then find limit extends to 0, f of 1 plus x by f of x whole power 1 by x. Here also x is equal to 0, substitute. It will becomes f of 1 divided by f of x is equal to, here x is equal to 0 if you substitute, this is f of 1, f of 1. F of 1 plus x by f of 1. X is equal to 0, substitute means it will become f of 1 divided by f of 1, 1 by 0. That means 1 power infinity. Whenever the limit reaches to infinity, here very important property you remember. Limit extends to a, f of x whole power g of x. It reaches to 1 power infinity. How to write this limit value is e power limit extends to a, g of x into f of x minus 1, like this you have to write and calculate the limit. Now whenever it is, this is f of x, now this is g of x, limit extends to 0, whenever it reaches to 1 power infinity, first what you have to write, e power limit extends to 0, g of x is 1 by x into f of x minus 1, which means f of 1 plus x by f of 1 minus 1. By applying this property, this limit procedure, you have to write like this, which is equal to e power limit extends to 0, 1 by x, take LCM, f of 1 is the LCM, f of 1 plus x minus f of 1. Now e power limit extends to 0, 1 by x, 1 by x, after that we will write f of 1 we can take outside, 1 by f of 1, f of 1 plus x minus f of 1 divided by f of 1, sorry x, that x we are taking this side. After that e power f of 1 value we have, it is 3. So 1 by 3 constant you can take outside. Limit x tends to 0, f of 1 plus x minus f of 1 divided by x. This bracket value is the definition of derivative of the function at x is equal to 1. That means f dash of x is equal to formula, first principle of differentiation, limit x tends to 0, f of x plus h minus f of x divided by h. But here f dash of 1 it is, that is equal to limit x tends to 0, f of 1 plus x minus f of 1 divided by x. So this bracket value we are going to write as f dash of 1, which is equal to e power 1 by 3 into f dash of 1. Derivative of function at x is equal to 1 it is. F dash of 1 value is also given 6. Therefore, e power 1 by 3 into 6, which is equal to e power 6 by 3. 3 ones are 3 twos are, which is equal to e square. E square it is there in the third option.